Exactly. Very good. Okay, so our goal for today is to just kind of solve by undoing. That's what we're going to go ahead and take care of today. More so today, not like the actual like step-by-step algorithm for solving by undoing. I'm sorry, this thing's beeping at me. Not necessarily the step-by-step algorithm for solving by undoing. We're going to do the applications of it today. So today's like word problem day. Woo. Okay. So with that, I just wanted you to review the algebra skills first, and then we'll start to apply those skills to finish up this particular section. So let me go to my spinny wheel of doom here, and then I just need the answers to B and C. Record them for the people who couldn't be with us necessarily today. So this is period 8, right? All right, here we go. Part B goes to, who's it going to be? It's going to be Benjamin Hupmeyer. No, you just have to tell me the answer. Well, I guess there's two answers, huh? You got to give me your equation, because you had to solve the equation for y. Yes, you're good. Okay, then when you evaluated x equals -5, what'd you get? -13 is what your answer should be. -13 is ultimately the final answer. Do you need to see it done out, or are you guys okay? You're good? Okay. Sorry, I was like unclear on that. All right, part C. So part C here, you have 2x plus xy equals 6. You're actually asked to solve that particular equation for y, and then you have to plug in an x value of 3. Shay? Okay, good. And then when you evaluated, what'd you get? Well done. Okay, questions for Shay or myself? Because those are correct. All right, so for part B, you got -13 as your final answer. For those people watching at home, sometimes they can't hear you, just so you know. You're like, they can hear me. Not always. And part C was -4. Okay. You ready to do some word problems? I think that's where we're at. Let's go back to example 2 for a minute. Now, please understand that every time I teach you a new word problem, I'm kind of teaching you a new template. If you think back to what we did with the paperbacks and hardcover books, so I'm referencing like number 26 from the 1.2 worksheet that we went over yesterday over here on the marker board. You know, every time I teach you kind of like a new formula or a new way to sort of do a problem. Let me be clear though, however, those 3 steps that we talked about don't change. So with that being said, who can tell me step 1 for taking a first look at example 2 right here? What do we do first? Endo. Yeah, you read the problem, pull out any information also. That's the other part of step 1. You have to identify what you know and also identify what you don't. So let's go ahead and do that first step, shall we? So step 1, read the problem. Example 2, it says write and solve an equation. So ultimately what we're going to do is we're going to write an equation, then we're going to solve it. Very similar to our paperback, hardback problem the other day. It takes you 8 minutes to wash a car. It's pretty quick. I'm impressed. And it takes a friend 6 minutes to wash a car. I'm even more impressed. How long does it take the 2 of you to wash 7 cars if you work together? There are a couple ways to go about this problem. But first of all, we just needed to kind of take a look and read it. 7 cars total. You could kind of consider that something that we know. Right now, I'm going to kind of segue into step 2. What's step 2 again? Maisie. Declare your variables. Identify what you don't know in the problem. A little tip, because as I move through today, I always say, you know, you folks have the sort of benefit of me having been through this class one time already today, so I kind of know where the students are having a tough time. In my experience so far today, and even a little bit yesterday, declaring the variable can be a little bit tricky, especially if the letter is not given to you. So let me give you a little tip. If you don't know what you don't know, look at the question part of the problem. That'll help you identify your variable. The question part of this particular word problem says, how long does it take? So I don't need to know how many cars there are. I need to know how long does it take. So can anybody help me with a variable? Offer one up. What do we know? You want to make it X? What does X stand for? Perfect. Yes, it's how much time it took, right? Time is measured in this problem in, yeah, very good. So that's going to be our variable. Kendall, good job. She wants to use X. And X is going to stand for, she said it, time in minutes. Usually, like, we write that in parentheses. So that's step 2. That's the only thing I don't know in this problem. I don't know how much time, I'm going to spend washing these cars and how many minutes my friend's going to spend washing these cars, and we have to wash a total of 7 cars. So that was step 2. Well done. Just a little preview of coming attractions. Time is our most popular control variable in any problem. We're going to talk about growing bacteria in a petri dish. What affects ultimately the amount of bacteria in the petri dish? Time. We're going to let you, practice throwing money into a bank account, saving some money in a savings account, mutual fund, something like that. Ultimately, what's going to control how much money you have in your account besides the interest rate and things of that nature? Time. The time you let it sit there, right? So time is going to be our most popular control variable throughout the entire course. And you see it now. It's nice. All right, so we did step 1 and we did step 2. We declared our variables. Step 3. What do we do next? Good, Joseph. What am I going to solve right now? You have some help if you're interested. Right behind you. Yeah, write an equation. Now, if you're not comfortable just jumping right in, full force, throwing in your variables, that we can write a verbal model to describe the equation and then write your equation. But yeah, in the end, the goal in step 3 is to write an equation. You're absolutely right. So when we did our, cost problem over here, we said, the other day, like the total cost of the books was going to be decided by taking your paperback books plus your hardcover books. Well, in this case, you and a friend are asked to wash some cars. So there's going to be the cars that you wash, and then the cars that your friend washes, and then total altogether, it has to add up to a total number of cars, which is actually given to us in the problem. So that's our verbal model right there. It's the total number of cars and then that's equal to the number of cars you wash plus the number of cars your friend washes. Remember, don't write it down unless it makes sense. That's one of our rules, right? Rule number 1, write what's on the smartboard. What's on the smartboard must go in your notes. Rule number 2, if you don't understand it, you don't write it. You stop writing and ask a question. I just saw everybody writing, so I think we're okay. All right. So let's start filling in some things that we know about this equation, shall we? For instance, the total number of cars. Do we know that? 7. Very good. Okay. I'm going to do the number of cars you wash. Okay. It says you wash, it takes you 8 minutes to wash a car. I thought I saw a hand up for a second. Okay, it takes you 8 minutes to wash a car. So if we want to figure out the number of cars you're able to wash, you wash 1 car every 8 minutes. And if we multiply that by X number of minutes, that'll tell me the number of cars. That was a mouthful. I'm going to say it again. Because I know some of you are probably like, why didn't you just multiply 8X together? So I'm going to explain it again. You wash 1 car every 8 minutes for a certain number of minutes. Who's had chemistry in here so far? Or maybe it's taking it. Yeah, okay. So there's this like, little thing called stoichiometry. You remember that? You had to like cross cancel your units. What's that? Okay. And like the mole. You'll talk about all this, but there's some bits where you have to cross cancel some units. So we have one car every 8 minutes times a number of minutes. What ends up happening is the minute unit goes away. You could cross cancel that unit out. And then what you have left over is the number of cars. So this little expression, 1/8 x, actually gives you the number of cars you're capable of washing. It doesn't give you a time, it gives you a number of cars, which is what we're trying to find. Okay, so let's see who can repeat what I just did. Bring down your plus. Who can write a variable expression to model the number of cars your friend washes? Yeah. So, do you mean this? Careful how you say it. Do you mean that? 1/6 x. Yeah. Amberly, do you have a question? Okay. Again, big reader of nonverbals. I don't want to, I like if you were like this or you're not writing, then I'm like, well, I'll just check on you. Sorry if I embarrassed anybody with that. It's a habit. Okay. Okay. Are there any questions about what's going on up here? We're good? Good job, guys. Way to hang in. All right. So let's pretty this up a little bit because now we're going to do Joseph's thing. We're going to solve this thing. So I have 7 equals 1/8 x. Now I have something I can solve. Plus 1/6 x. I have a cool trick I'm going to show you. Who loves fractions? You're kidding me. Get out. Nobody really like hearts fractions? Make yourself a little t-shirt. I heart fractions. No. What is it? Like less than number 3 fractions? Yeah, most of us would. I love where you're going with that, Joseph. Okay, so if you don't like fractions, I'm going to show you a little trick to get rid of them. And then I want you to practice this. You're going to have some independent practice problems here in a few minutes. I want you to practice this skill just a couple times on the independent practice and then maybe a couple times on your homework tonight. So what do you do if you have fractions in the problem, especially if they have different denominators and they don't combine easily? I'm going to show you a trick to get rid of them. But Maisie, do you know what you would do? You do get a common denominator, and then you have to change the numerators to correspond to the change you made in the denominator. Yeah, okay. So it's annoying. I understand. I'm going to show you a little bit of a trick. We use this trick like all year long, especially, I know we can look forward to it now, but like in May, we use this trick quite a bit to get rid of some denominators in our rational expressions. So here's how this goes. It's called the LCD method. Do you know it? You probably have done it, yeah. This little trick I'm showing you is called the LCD method. You guys remember what LCD stands for? Yeah, so you still have to figure that out. To review, least common denominator, least common multiple, is the smallest number that 8 and 6 both go into. It's actually for every fraction in the problem, to be quite honest, so you could put the 1 there. But our LCD method has us finding the smallest number that both of those things go into. So what is the smallest number that 8 and 6 both go into? Good, Claire? It is 24. Very good. So do you see how I put a big bracket around my whole problem there? And now what we're going to do, we have a 24 outside of the parentheses. We're going to use the distributive property right now. And we're going to distribute that particular 24 into every piece of the problem. This is the multiplication property of equality. What I do to one side of an equation, I must do to the other. So you can't just do it to one side, you have to do it to everything. Okay, then I have to take 24 times 7. Anybody know what that is? 168. 1/8 of 24 is just like 24 over 8. Do you know what it is? Yep. And then I have 1/6 x times 24. 1/6 of 24, Skylar. 4x. Woo! Fraction's gone. So nice. So nice. You like that, right? It's nice. So we have 168 equals 7x. Divide both sides by 7. Bam. That's kind of nice. You get 24 again, right? So how long does it take you and your friend to ultimately wash those 7 cars? 24 minutes. Not too bad. Does anybody have any questions about that? I hear like a couple whisperings here and there. There's a way to get the LCD on a calculator. Yeah. I think your calculator calls it like GC. No, it calls it LC. It's like a weird thing. It's under math. Oh, yeah. Well, that's not that weird. But it calls the greatest common factor GCD. I don't know why it does that. Okay. So let's review. I know after I do a word problem, you're like, really? We have to talk about it again? But yes, just to make sure you understand the process. We read the problem. We pulled out the information that we knew. We knew we were going to try to wash a total of 7 cars. We knew that I was able to wash 1 car every 8 minutes and my friend was able to wash 1 car every 6 minutes. So we used that information and then we decided what we didn't know. We didn't know how long it was going to take us to wash these 7 cars. That helped us define or declare our variable. So that was step 2. I didn't know the amount of time. So my variable was x equals time in minutes. I then wrote a sort of a verbal model. I know that to wash 7 cars total, I have to wash some cars and my friend has to wash some cars. So then I went ahead and I wrote my variable expression for each of those things. Total number of cars was 7. We talked about the 1 car every 8 minutes times the number of minutes I can spend washing a car. 1 car every 6 minutes times the amount of time my friend can spend washing the car. And we solved that equation using the LCD method. No issues? Okay, so that was another example of writing one equation in one variable. And as I walked around and checked your 1-2 practice B yesterday, it only happened a couple times in all 3 periods that I teach this class, but some of you are quite eager to introduce another variable. So I wanted to take some time right now to kind of show you an example of a problem where you have to introduce another variable. And that's going to be our next example. So we have a movie rental problem. Before we jump on into this problem, I do believe there's a typo in your note packet that I just want to quickly fix with you. It's in part D, number 3, right here. You can cross out the $sign. I think the $sign is still hanging out in your note packet. Shouldn't be there. If you read the question, it makes sense why the $sign has to go away. It says, how many new movies must be rented if the number of older movies rented is $500? What? A number of movies isn't going to be in dollars. It's going to be 500. Yeah, so just cross off your dollars. So there's a dollar symbol, just cross that off. All right. So, step 1, we read the problem. Part D, a video store rents new movies for one price and older movies for a lower price. Oh no, where are the prices? Oh, very good. Yeah, sometimes in math class, this happens in your math book too. I'll get questions like, I don't know what the price is. But in the math book, you have to pay attention to the pictures. There's important stuff in there. In your social studies book, if you're studying, a little bit about the precursory stuff to the Revolutionary War, and you see George Washington crossing the Delaware River in a boat, does that picture necessarily reinforce to you anything about, the founding of our nation? Not so much. But in math class, you need to pay attention to the pictures. So here, yeah, you do get some important information. New releases are $5 per movie, and the older movies are $3 per movie. The bargain. Yeah, if there were video stores around anymore. Okay, so we have, that was us sort of reading the problem. In part I, we are asked to write an equation that represents the store's monthly revenue. So revenue, do you know what that is? We haven't talked about that word yet. Revenue, yes. Like, ooh, okay, profit is different from revenue because profit is actually determined by the difference between revenue and cost. So there's a difference between revenue and profit. How much money they bring in, there you go. So make could be confused with profit. If I'm an owner, what I make, my salary is usually off of profit. So with that being said, what we're going to go ahead and do is write an equation for revenue. So revenue is going to come from two places. And I'm just writing my verbal model right now. I didn't write my variables yet, I know. Out of order, Mrs. Lucas. Okay, so revenue is going to come from two places. Anybody tell me where? Go ahead, Joseph. Old movies and new movies. So it's going to be the amount of money earned from new movies and add that together with the amount of money that we earn from old movies. So in every equation we've studied so far in this class, you're doing a dependent variable equals something plus something else. That's the pattern that you're seeing, kind of like a linear pattern. Okay, so now we need some variables associated with old movies and new movies, right? So new releases, the number of them. We know how much they cost. New releases cost $5 a piece. But if I want to know, if I want to know how much money I actually make from all of my new movies, I probably need to know how many I sold or rented in this case. So I need a variable. This is me declaring my variables for the number of new movies. I need somebody to pick a letter. A. Lovely. So this is going to be my number, not the amount of money from, because I know that. A is going to be my number of new movies. Okay, older movies. Should you use O? No, never use a variable O, because it looks like 0. That'll be true forever. Your Algebra 1 teachers probably talked to you about that. We don't use O as a variable. So yeah, I need a letter for older movies. R. R, are you like pirates? R, maybe. Let's go box. All right, so number of new movies, number of older movies. So now we can go ahead and write our actual equation. Revenue. Oh, I wanted to call that one R. Can we pick a different letter for older movies? I wasn't thinking. Sorry. I forgot revenue was our dependent. Okay, so we have R here equals the amount of money from all the new movies. Well, if our new movies are $5 a piece, and I want to know how much money I get from them in total, I have to take $5 times the number of movies that there are. So, bless you, this is going to be 5A. Bring down your plus, amount of money from old movies, times the number of old movies that I actually rent will give me the total amount of money for my old movies. So that's 3S. Now I'm supposed to solve this revenue equation for the variables representing the number of new movies rented. So we have this simple equation right now. I'm actually going to toss this one out to you guys. We're supposed to solve for the number of new movies. So we need to solve this equation, just like we did in the warm-up problems. You need to solve that equation for A. Okay, so I'll go ahead and give you a second to do that. Let's see what you have. All right, let's walk through that because you're probably not alone. So we go backwards through the order of operations to solve for A. Okay. So we have to undo any subtraction or addition that we see in the problem. So do you see any addition? Yeah, what am I going to move to the other side? Yeah. So we now balance the equation, right? On the left side, you have R minus 3S. Billy, what do you have left on the right side? 5A. Now you need to get A by itself. If we're SAD mapping, we have to undo any multiplication or division that we see in the problem. I do see multiplication, do you? By a factor of 5. How do you undo multiplication? Divide both sides by? Yep. So you could just write this as A equals R minus 3S over 5. Or you could actually divide that 5 into both things. So there is more than one correct way to write this particular equation. Like that. That's an option. All right, and I'm going to let you guys have at this one also. Do you have questions about that, Billy, or are you okay with it? Okay. Okay. So in part 3, it says the owner wants $12,000 in revenue per month. So now what we have to do is let R equal $12,000. That's how much he needs to bring into the store in a month. How many new movies must be rented if the number of older movies rented is 500? So we have our N is a big unknown right now. And our older movies, sorry, you said A. And S is our older movies. Our older movies is 500. So if you want to take some time right now, you're going to tell me what A is. How many movies? How many new movies must be rented? Let's see here. Mark. Did you get it yet? Did you get it? Yep, perfect. 2,100 new movies. Questions about that for, ooh, go ahead, Macy. Yes. No. Okay, I thought you were asking me if that's my handwriting. So I have it as 3/5 S. The other way you could, so you're asking me about this part, correct? That's also like that. Oh, yeah, it's right. It's not divided into, it's divided by 5. Yeah, okay. Just making sure we're on the same page. Any other questions? Go ahead. How do you do when you say that? Like from the beginning? Okay. Okay, so again, it's like one of those SAD map type things. So if you're just focusing on right now, where was it? This equation here. So you're not able to get this part, is that right? I just want to make sure I understand your question. You got this part. So what's in red is what you don't understand. Okay, so if you're going to go ahead and figure out what our number of new movies is, the revenue was 12,000. So I used my property of substitution, and then I subtracted basically 3 times 500, and then you're asked to divide that by 5. So 12,000 minus 1,500 divided by 5 is what you're working out. So really you get 10,500 divided by 5. Well, I know 5 goes into 10 twice. 500 is going to be 100. 2,100. I always wrote novies. And I guess it would be new movies if we're getting technical. You good with that? I did the order of operations is what I did.
Yeah.
Okay. Anything else? All right. So, like I said, I did want you to practice that LCD method once or twice, just to make sure it goes okay for you. It is a shortcut we're going to lean on quite often. I tried to fix up the problems in your book so they looked a little prettier, but I don't know that it necessarily came out all the way, so I was going to copy these down for you. If you're having trouble looking at those, this is what they're supposed to be. And then part C wasn't typed in equation editor, so that one should be okay. If you could, try the LCD method. You could do it on A and B, but definitely on A. So I'd like you to go ahead and give that a try. We're going to go over those answers in just a minute. And now you are fully equipped to finish your assignment over the weekend for 1-3 Part B and 1-4 Part B. I will use the last couple of minutes today to go over any questions that you guys had with regard to those of you, that started that assignment. And then I'll be looking for that assignment, like I said, on Tuesday when I come back in. That up, especially if you use the shortcut. I see you guys drawing this one to a close. Yeah, the LCD that I see you guys using, good job, is 12. So if you take 1/4 of 12, that's 3R. 1/6 of 12 is 2R, and then that's equal to 60. So you get 5R equals 60, or R equals 12. That's your first answer there. For your conclusion,